The server becomes the attacker. Imagine a website that fetches an image from any URL you give it. You expect the server to fetch a public image. But what if an attacker makes that server request something private instead? That is the dangerous idea behind server-side request forgery. The real-world feature SSRF often starts with a legitimate feature. Import an image, preview a link, fetch a webhook, convert a document, or retrieve data from a URL. The application receives a URL from a user, then its backend server connects to that destination on the user's behalf. Direction: visual URL preview form. What SSRF means server-side request forgery happens when an attacker can influence where the server sends an outbound request. The key distinction is simple: the attacker is not directly reaching the protected target, they are persuading a trusted server to reach it for them. Direction: visual trust boundary diagram. Why server location matters. Servers often have network access that ordinary internet users do not. They may reach internal APIs, management panels, databases, service discovery endpoints, or cloud metadata services. So the same request can have very different privileges depending on where it originates. Direction: visual, public. Normal behavior in a safe, intended flow: the user submits a public HTTPS URL. The application validates it, the backend fetches the approved remote resource, and the result is returned to the user. Sender, destination, and response all match the feature's purpose. Direction: how SSRF changes the flow. The vulnerability appears when the backend trusts the supplied destination too much. An attacker replaces the public URL with a location the server can reach, but the attacker normally cannot. The server follows that input and crosses the network boundary on the attacker's behalf. Direction: visual, input swaps from public host to internal target. URL preview service: consider a link preview service. Step 1, the attacker submits a crafted destination. Step 2, the public application accepts it. Step 3, the backend resolves and connects to an internal service. Step 4, any returned information may be reflected back through the preview feature. Direction: visual numbered 1-4 pipeline. Animation: the vulnerable pattern at code level. The risky pattern is not a particular programming language. It is a trust mistake. Take user input, pass it directly into an outbound HTTP client, and return the response. If scheme, hostname, resolved address, redirects, and destination policy are not constrained, the server can become a request proxy. Direction: potential impact depends on what the server can reach and what the response reveals. SSRF can expose internal service data, probe internal network paths, trigger unintended actions, or reach cloud local metadata. The serious risk is the combination of server trust, network position, and insufficient outbound controls. Direction: constrain the destination. The strongest defense is to avoid arbitrary server-side fetching when possible. When fetching is required, use a strict allow list of schemes, hosts, ports, and expected destinations. Resolve names carefully, reject private and local address ranges where they are not required, and recheck the destination after redirects. Direction: visual, validation gate before network. Defense in depth: do not rely on input validation alone. Restrict the server's outbound network access, require authentication on internal services, protect cloud metadata using platform controls, log unusual outbound requests, and design response handling so sensitive internal content is never blindly returned to a user. Direction: visual. Key takeaway: remember the SSRF mental model. User controls destination, server sends request, private network trusts server. Break any one of those assumptions with strong Thank you for watching. Direction: visual, handwritten.